proceed.
Okay, so hello everyone. I'm RASHMI BAKSHI and I will talk on my topic, a comparison of deep learning models for the prediction of hand hygiene videos. So to start with, in European Union, every year 2.5 million cases of hospital-acquired infections occur. And the main reason for these infections is MRSA, which is a bacteria that causes the cross-transmission of diseases. And the research has shown that good hand hygiene practices can reduce the transmission of this bacteria and therefore save us from spreading the hospital-acquired infections. So when we say good hand hygiene practices, WHO, World Health Organization, has come up with 6 standard procedure for washing hands. And our goal in this project is to automate the hand hygiene stages and to develop a system that could ensure hand hygiene compliance among healthcare workers. So to start with, we have created a data set for hand hygiene video recording. And for this, we built an aluminum rig and we mounted the camera devices on the aluminum rig. It was imitating the healthcare setting. And we recorded postgraduate researchers for their hand washing process, and the training was given to them before how to wash hands according to the WHO guidelines. And the data is collected from 30 participants in a video file of length 25 to 30 seconds with all the covering all the stages. So that data set is then used with deep learning models. So in Keras, there are existing pre-trained models on ImageNet dataset. So ImageNet is already a dataset with 1,000 classes and with greater than 1 million images. It is already trained. These models are already trained with ImageNet. We are using transfer learning, meaning we are using these models for our own application. So in this paper, we have used exception, ResNet 50, and inception V3 models. And in order to use these models, we created 3 classes manually. So from the video recordings that we collected, we created 3 classes: fingers interlaced, fingers interlocked, and rub hands palm to palm. And the number of images in all these classes were more than 1,000. It is still a very small data set, but it is good to experiment and get the results, and then we will further increase the data set. So the methodology is to create manually the data set. Then the data was split into training and testing set based on 75 and 25% ratio. After that, we fed the model and the head of the fully connected layer was reconstructed. The model was compiled for 25 epochs meaning training steps. And after that, using sklearn, a high-level library, we computed the classification report that gives us the accuracy, precision, recall, and F1 score. And then the prediction was made on a new data that wasn't fed on the fed in the network in order to see if the predictions are right. So the results shows that ResNet 50 is a residual network where instead of original mapping, residual mapping is used, and it gives the highest accuracy with 72% accuracy achieved. The only limitation is that it's an accuracy speed trade-off. So meaning that for higher accuracy, the speed was really slow, and that is because we were using Intel CPU, and for deep learning and transfer learning models, we should use GPU. So in future work, we will be using, instead of Intel, we will be using faster specifications such as GPU. So this is just to show the results of the frames, what I have. So in the first image that you see, palm to palm is correctly identified as palm to palm by exception model, but then fingers interlaced is incorrectly classified. In the second image that you see, palm to palm is correctly classified as palm to palm. Fingers interlocked is also correctly classified, but again, fingers interlaced is misclassified as fingers interlocked class. So this prediction is coming from inception V3 model. The last image is the image from ResNet model, that is a residual network. And in that, the model correctly classifies all the images. So fingers interlocked is classified as finger interlocked, fingers interlaced is classified as finger interlaced, and again, palm to palm is classified as palm to palm. So giving us the correct prediction, showing that ResNet 50 should be explored for further future work. So the future work will be, we used only 3 classes with only 1000 images for this data set. But in future work, we will be using complete hand hygiene data set that we created. We are also collaborating with the public hospital here, with the public healthcare setting, to record data from the healthcare workers, that is nurses and physicians, in order to do our research. And we will be using, again, GPU NVIDIA systems for our future work. So thank you.
Thank you very much, ma'am, for your presentation.